Hi, Mrs. Bricky here. This is going to be sections 2.1 and 2.2, a total of 7 topics, though I believe everyone's already passed off 2 of the topics. So I'm not going to even talk about those in the video. Basically, we're going over 5 topics. Here's a schedule for Unit 2 lessons and due dates for Unit 2. Coming up soon is a practice test, January 29th through February 2nd. And in the sort of near future, midterm test 1. All right, so section 2.1 is really just 2 topics, which is the distance formula and the midpoint formula. So starting with the distance formula, Alex is going to want your answer in exact form, which means if it's a radical, we don't want a rounded decimal answer. We want that exact radical. The distance formula is on your reference sheet for the class, so you will have that available to you. I don't prefer to use the distance formula myself, at least not like as written here. I prefer to just think of these things as right triangles and use the Pythagorean theorem. Thinking about them as a right triangle is a useful way to avoid sign errors. So here are 2 points. Point C is -6, 9, and point F, point F is -1, 2. And so our question is, how far apart are these 2 points? Even a really rough sketch on a coordinate plane will allow you to use a right triangle to answer this question. So basically, we're wondering, what is that hypotenuse? Well, the length here along the bottom is 5 because we're between -1 and -6, and the length of this other leg from 2 to 9 is 7. So if we think of it as a Pythagorean theorem question, it would just be 5 squared plus 7 squared is equal to d squared. 5 squared plus 7 squared is 74. And so then we would take the square root to get our answer. Now, sometimes this radical might simplify. So you do want to simplify that if possible. So for example, if it was the square root of 20, that would be 2 root 5 and so forth. And most of you have I think have the calculator that will simplify radicals for you. So no worries, just use the calculator to help you simplify that. Please do not, again, turn it into a decimal. We do want it exact. So this would be our answer because root 74 does not simplify. You could get that exact same answer using the distance formula, and you can kind of see parallels between them. It just uses the coordinates. So we'd have x1 minus x2, and then we'd have y1 minus y2. And so you can see that these little bits of subtraction are what give us the sides. Whoops, 7, not 5. But easy to have an error, easy to accidentally get a 7 here. So that's why I like the visual of just finding those side lengths. But again, you do get the same answer, and you do have the distance formula on your reference sheet. So the next one is the midpoint formula. So if you are trying to find the midpoint of a line segment, it's just the average of the x coordinates and the average of the y coordinates to get the coordinates of that midpoint. And midpoint is a point with 2 coordinates, not a single number. So we're going to try to find the midpoint of this segment. And so, we're going to expect our answer to be somewhere around there. It's not quite the middle. Close enough. So again, it's just the average of the x's and the average of the y's. So the x's are -4 and 8. So if we average those, we get 4. 4 halves, which is, oh, that's not erasing. 4 halves, which is 2. And for our y coordinates, we have -2 plus -5. So that's -7 halves. And you probably just want to leave that in a reduced fraction form. I wouldn't take that into a decimal. So that's our midpoint. And I would not be worried or surprised if you have a fraction as one of your coordinates. Okay, section 2.2 is focusing on circles. So you should be familiar with the circle equation from prior math classes. So if we have a circle with a radius of r centered at point hk, the equation is x minus h is squared. We add y minus k squared, and that's equal to r squared. And that equation will give you the graph of a circle. And the r is always a positive radius. So here are some examples. That first example is probably most similar to ones you've done in prior math classes where the radius is a nice whole number. The radius does not need to be a whole number though. So if, for example, the radius was square root 12, in the equation you would see a 12 there because the square root of 12 squared is 12. Also, you probably haven't seen a lot of circles that are centered at half point values. That's fine. There's no problem there. So it doesn't have to be a whole number center. And then if the center is at the origin, the equation just looks like an x squared plus a y squared because x minus 0 is just x. So you should be familiar with that. The first topic is to graph a circle when the equation is given to you. So the first thing you need to identify is the center. So it's like when you're solving factorizations or when you are graphing translations, you do want the x value that makes that factor 0. So it's a -6, 3. So you do have, I guess, sometimes we think of it as a sign change because we're looking for an x value and a y value that create zeros there. All right, so our center is at -6, 3 right here. And Alex, it's pretty easy to graph the circles. The tool will kind of show you what to do, but you mark the center. And then you need to know the radius. So just remember that in the equation, that's an r squared. So the radius is the square root of 9, which is 3. And there's our circle. Next topic is to create the equation of a circle that is centered at the origin. So centered at the origin just means that our equation is going to look like the most basic type. X squared plus y squared is equal to r squared. But we do have to figure out the radius. It's not directly told to us. So we know the center is at the origin, and it gives us one other point. So it says it goes through -5, 0. So that is a super fancy way of telling us that the radius is 5. So this is going to be a 5 squared. So the equation we would want to type into Alex is x squared plus y squared is equal to 25. All right, this is the last one, and definitely this is one of the hardest topics of Math 1050. Not because anything is particularly difficult that we need to do, it's that there are so many steps to answering this problem that it's just easy to get one little part wrong and then miss the problem. So the scenario here is that we are trying to find the equation of a circle, and the information that it's going to give us is the diameter endpoints. So this circle, and I'm going to use a graph to help me, and I think that is a great strategy to always kind of graph these. So it tells us that diameter has endpoints at -5, -4, and at 1, -1. So here is our diameter. So the circle that we're talking about looks like this. And so what's challenging here is that we don't know the center and we don't know the radius. So those are the two things that we have to figure out. We have to figure out what is the center of this thing, and we have to figure out what is the radius. So to find the center, we will use the midpoint formula, and that would be our first step. So the midpoint formula is just the average of the x's and the average of the y. Whoops, not comma. And so that puts our center at -2 for our x coordinate, and our y coordinate is -5/2. And again, it's completely fine that that's a fractional value. It's the same as -2.5, and you can kind of see that that center that I just calculated just completely matches what my picture looks like. You know, it's the x coordinate is -2, and it's between the -2 and the -3 in the y direction. All right, so we know the center. So we could, in theory, write the first part of our circle equation. It's going to be an x plus 2 squared, and we're going to add a y plus 5/2 squared. So now to finish it up, we have to know what the radius is. Well, to find the radius, we are going to use the distance formula. So we want to know this distance here, and the radius is just going to be half of that. Now, if your center is at sort of a nice whole number point, you might just directly find the radius from center to edge, but especially when my center has a fraction, I like to use the entire diameter to figure out the radius. So I'm going to draw a little right triangle here. My right triangle is this one. And so you can see that the height of that is 3 and the length is 6. And so to calculate the radius, I first get the diameter. The diameter squared is 3 squared plus 6 squared. Well, that's 9 plus 36 is 45. So D is root 45. The radius is half of that. So the radius would be 3 root 5 over 2. And in my equation, what I need is r squared. So that would be 3 root 5 over 2 squared. Well, you can type that into your calculator just the way I have it written if you want, or you can do it bit by bit, but 3 root 5 squared is 45, because this is a root 45 squared, and then 2 squared, don't forget that the denominator also is squared, is 4. So, and 45 over 4 doesn't reduce, and so that would be our circle equation. So you kind of have 3 steps there. You need the center, you need to figure out the radius, don't forget to square it, and then you're ready to write your equation. So lots of steps on this one. All right, so let me know if you have any questions or troubles. Thanks so much.